Alright, so I went ahead and added another file menu option, Open XML. So we're going to go into XML now. So this menu item is simply going to open up this other dialog box, which is my XML form. And then we'll manage actually doing the opens from here. So this we'll do using OpenXML or XML form equals new XML form dot show dialog. Alright, so for this form we'll need an open file dialog, and then we will, let's see, I'm going to add some specifics here, so I'll do a filter. So I'll say XML files start.xml. So when we do this, we'll say if open file dialog 1 show dialog equals OK. Open XML. Alright. So F5, just make sure these basic mechanics work. Open file gives us the ability to open up an XML document. Don't have any. So let's start by creating one. To the desktop, my favorite tool of choice for text-based files, Notepad++. If you're not that familiar with XML documents, I recommend going through this tutorial on W3 Schools. Even if you are familiar with it, but you're still like rusty at it, not totally sure what you need, this is a pretty good one. It's free, it's online, it gives you pretty much everything you need without having to watch a video or buy a book or anything like that. Basic components of an XML document, just so we all have the same terminology down. We have the doc type, which is the very first line of any XML document. You then have elements, which are the tags, most commonly referred to. Those are called elements. You can have nested elements or child elements. There's always a base document element. In this particular example, it's note. It then has child elements, to, from, header, or heading, and body. There must be one base or one root element in every XML document. You can't just start off by doing to, from, header, and body. We're going to the next. I like this statement. XML does not do anything. It doesn't. It's a good way to store text, but it itself has no functionality. You invent your own tags. It is not a replacement for HTML. And it is everywhere. Alright, come on. Where's what I'm looking for? Yep, you've seen that document. Okay, so I just want to give you the... So, bookstore, root element. Book, child element underneath it. Category is called an attribute in XML and HTML. Anything that's within the brackets, the angle brackets of an element that is a key value pair or a name value pair is considered an attribute. The attribute name is the part to the left of the equal sign. The attribute value is whatever's in quotes. Good XML notation requires that your values be in quotes. If they're not, your parts are illegible. Elements can have can also have inner text or text values within themselves. So title, for example, Everyday Italian, that's the title. It has an attribute of language, which is English. Lang equals N-E-N. Book has a category of cooking. It's preference. There is no convention to tell you how to write your XML document structure, but once you define it, it's best to standardize on something. Category could be another one of these angle bracket elements, so you could have less than sign, category greater than sign, cooking less than slash cooking or slash category close. They work just the same. You can nest elements, you can't nest attributes. That's the fundamental difference. Alright? So, what's the big deal about elements and attributes and child nodes and root nodes and blah blah blah? The reason I tell you all this is because, one, oh shoot. I just forgot. Oh, that's fun. I just forgot the basic doc type. There it is. So we're going to create an XML document. Does it matter what we use? Not really. So let's go with midterm, the models we use. So this will be a pharmacy. So inside of it we'll have patients. And let's just do patients. That'll make it easy. So the patient will have first name, last name, email, phone, and patient ID. Alright, so that's a patient. Going to add multiple patients in here. Phone numbers are relevant. Okay. So we're now creating an XML document. So this will be our patients.xml. All right. So from inside of C#, we can now take this document, and we can open it, and we can read it. Now we could do like we did before, and we could simply say something like file.system.io.file.open. We could do open text and point it to the open file dialog 1.file name. And I don't have a text box because I expected it to be data, so we'll do show message or message box.show data. String data equals that. So F5. So what is this? This is stream reader. Stream reader SR equals this. Using stream reader SR, and we'll say read to end.
Store that in data, string data, F6, F5, file open XML, open, it should read patience,
and there's the XML that we just typed in. Very nicely formatted for this one.
But if we actually wanted to do anything with this, we're dealing with text.
The XML documents normally don't come across as small documents. They normally come across as these giant behemoths that are extremely complex and that are trying to model entire databases. All right. So, how do we deal with them in a much more functional way?
If you have a good data structure to your XML document, come on. This is read as text. If you have a good structure for your XML document, you can read as dataset. If you have a bad structure for your XML document, you can read as XML document. And I shouldn't say a bad, but a complex structure. If you have a very linear structure where it's very simply defined and it's consistent, we can read it in as a data set. And what that does is it takes that XML document and basically converts it into a database or a database table. So I'm going to start there and then we'll work through treating it as a true XML document. Within system.data, there's a dataset class. We can create a new instance of that dataset, and then we can say dataset.read XML. We pass to it a stream or a file name. Just so I don't have to type it over and over again, we'll say string file name equals open dialog dot file name. So then I can just refer to it as file name. So that will then go in and read the XML document. Going to put that there so I can put a breakpoint on it.
So what I want to have happen is I want to create my data set, I want to read that XML document, and then I want to show you what it means for that data set to suck in that XML document. F5. So file XML, open, patience, and we now have a data set with data in it. If I click this, this is a dataset visualizer. It takes the dataset and actually shows us what is inside of it. So there's the root element, so it's kind of side by side this with what little screen real estate we actually have. File does not know, because I changed the name to that. Alright. So, what does the data set do? It says, all right, I'm going to try to take this structure and I'm going to turn it into something that looks like a database. So it starts off and it says root element, root node. It is what it is. It has to be there. It doesn't mean anything. It then says, I'm going to go to the next, or I should say the first child node, and I'm going to assume that this child node is an entity structure. It's an object. It's a something. And it treats it as a table. And it then says, okay, patient, we're not going to refer to it as a data table, an in-memory table name. Table name patient. So that transitions to table patient. It then goes and attempts to find every element, every instance of the element of patient, and does kind of a diff and merge across all the element names, child node elements, and attributes within any instant of patient. In doing that, it says first name, first name, first name, first name, oh, first name. Pretty cute. Last name, last name, last name, field. Email, 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 field. Phone, 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 and then it's behind here, patient ID, and makes a column for it. So now we can treat our XML document as a database. We now have rows, columns, data.
What's nice about that is we can then use data controls
And bind this structure to a data control on a UI when gives the user something easy to interact with. We can also treat this like a database. So we can now do select statements. We can serialize this into objects, just like we did last week, because we're dealing with rows of data. And we can then take what we would normally store in a database, store it inside of a data set, and there's a read XML, there's also a write XML, and write that data set, that database, back to an XML document. So instead of needing SQL Server or MySQL or whatever to store and restore data, you now can simply read and write from that XML document.
And XML is obviously a lot more portable than SQL Server. So what happens if I come in here and I say street address?
It attempts to handle that in the best way it can. Again, it does that diff and merge. So it now sees that there's another column, because there's another element in the XML document called street address. So it creates a column, and wherever there's data, it fills it. And wherever there isn't, it leaves it blank. If we were to take this data set and save it back to the file, it will create a street address element in every instance of patient that didn't have one. It'll leave it empty, but it'll create it, because it's going to work to standardize the XML document as much as it possibly can based on the information it has. Now, doing this is a lot of heavy lifting. It's nice because if you're dealing with data and you actually want to deal with data, putting it inside of a data set gives you that liberty. If you have different types of data, you have patients, you have maybe medications, doctors, all of that in here, modeling that in the data era in the XML document is relatively simple. So if we want to add doctor, we now open patient again. We now have two tables. One's patient, one's doctor.
The doctor table, again, infers what it can based on the data that's provided. So it creates a table with two fields, first name and last name. They are treated as separate tables. So we actually are starting to build a database. We could add another table in here for medications. We could then add another, or not a table, but another XML or a node element that is medications, and then we could even build one that builds relationships between them. Now let's say that it was it was a lot more complex than just simply pulling it in as a database, or the data set is attempting to parse it in such a way where it's trying to make it overly complicated. Maybe our data, our XML data is so simplistic that bringing it into a data table, going through that work of parsing the entire XML document requires far too much memory. The system can't do it. You're wanting to search through this entire file and find specific elements, but you don't want to load it into memory. You just want to find the pieces you need. Instead of using the data set, we can go the other route and read it as an XML document. Okay? The last thing I did want to show you before I go on to that, though, was so data grid view. So what I did on the form is this big gray space is actually Toolbox under the data section, data grid view. I can say data grid view data source equals ds dot tables patient, and I can bind the patient table to the grid. And then within our application, we get that same experience. Now this grid can be configured to be editable, so you can just load up all that XML data, show it here, type in the fields just like you would an Excel spreadsheet or an Access database. We can then write a save method where we pull that data back down, take it from the data set, save it into the XML document, and then we now have a full circle process for editing that XML document without having to launch it into Notepad or whatever and actually do those manipulations. Does anyone have an interest in seeing that before I go on to the XML document? Okay. I just need yeses or nos. Or indifferent faces means no. Okay. Is there some yeses? No? Okay. I'm not going to waste your time if you don't care. Alright. So, reading an XML document. There's a system.xml namespace, XML document class. The constructor takes basically two possible options: null, no constructor, or taking an XML name table. When you start to learn more about XML and this concept of namespaces, that becomes relevant, but we don't have namespaces in ours, so I'm just going to create a basic one. So xdoc read, where is it, load, and you'll notice that load, there's two loads. There's just load and there's load XML. Load XML takes in a string. Load takes in an XML reader and three other overloads. First overload's a string. Second overload's a file name. Third overload's an XML reader. Fourth overload is a text reader. I'm just going to go with file name. We don't need this. So XML documents, once we've loaded, they have a lot of navigation methods and properties. So append child allows you to append an XML node to the document. Attributes goes through and gets all the attributes on the current node. Everything within an XML document, every element, well, I shouldn't even say that. Everything within an XML document is considered a node. Attributes and elements are both considered nodes. Text itself within an element is considered a node, technically. XML documents are recursive by nature. So what that means is that regardless of where you are in the document, it's always assumed that there are parent elements potentially and there are child elements potentially. There are attributes potentially, there's text potentially. So you are always going to see those four things projected out through every class as it relates to an XML document. So you'll see attributes, you'll see child nodes, you'll see the ability to create comments, see data sections, document fragments. Document element itself is the root element. Document type is the doc type. First child is the first child element to this node. This node being the root node. A Boolean of has child elements. Inner text will give you the text within an element. Inner XML will give you not just text, but it'll give you the full XML markup. So depending on the type of data that's within that node, you may want to get inner text or inner XML. You can do insertions before or after the element you're sitting on. Here's those namespaces again. As you're traversing, you can look at the next sibling back and forth. Node type, outer XML, owner document, patient node, or parent node, which is the node that that element or node lives within. Schemas, value, which is another simple way of getting access to the text within a particular node, or the value of an attribute. Alright, so let's do some real basic stuff. So, if we say document element, you'll notice the return type here is XML element. This is the root element. This is our pharmacy element. If I say root dot, let me do an include. Well, let's do it. Let's start outer XML. We do an F5. File XML. Open. There's the XML. Outer XML, which includes the element we're at and everything itself and everything within it. So there's pharmacy patient, there's all the patient data, Notice it trims out and removes all those line breaks and tabs and everything, so the formatting is consolidated. And it just basically spits out the text. If we say inner XML, we don't get the pharmacy element. We just get patients. If we do inner text, it actually goes through and it strips out all the markup and just gives us the text within those elements. Now, you may be looking at that and say, what good is that? Nothing. In this case, nothing. But if we wanted to, we could go in one level deeper and say root.child child nodes. And child nodes is considered an XML node list. We can put a for each statement on this. And we could do something like messagebox.show node.innerText. So there's the first element. There's the second element. So we're now beginning to walk each one of these one at a time. There's the doctor at the end. We could say if node dot name equals patient. Actually, let's do it this way. Equals patient. There it is. So we're now restricting and only showing patients. Patient 1, patient 2, end. So we're now traversing the XML document based on the information we have. Patient class. So we can go through then and we can actually parse values out of that XML node and create a patient. So we'll say here lists patient, plist equals new patient list. So patient P equals new patient. So create an instance of patient in P. And then we can say P.firstname equals node.child. And this is where it kind of gets complicated because we start to say, okay, how do we, right now we just keep doing these loops. We're looping over everything and we're trying to find these nodes and trying to fill them in. So we could put another loop inside of here and say, for each node, if the node is first name, take the value and put it inside that property. So that would look something like this. So for each XML node, patient data in node.childNodes, probably do like a switch. So we say patient data.name, scroll this up here, case, first name, do something, break, and it would probably be p.firstname equals patient data.innerText, case last name, p.lastname equals patient data.innerText, break, case, email, I'm not going to do all these, p.email equals patient data.innerText, break, and you get the drift. So then we have our complete patient, add to list, so then we do plist.add p. And then when we get down here at the very end, we should be able to see all of our patients in that list. So F5, build error. No. So it iterated through all of that. plist has just one item in it. You probably need to go further. So there's the first item. If we continue, plist now has two items. There's the second. So we've now taken that data from that XML document, using the XML document class, parsed that document down, and are now creating objects from it. And the last loop there, third loop, was the doctor. We didn't get another patient. So this work is kind of intensive. It's kind of laborious, but it could be argued as being most efficient. You have to touch every element. You're doing the work. You know exactly what's going into it. There are mechanisms that make parsing and capturing data much more efficient, though. And I'll just show it to you real fast. I don't want to take a lot of time. But it's something that's definitely worth researching if you ever end up in a situation where you're dealing with a lot of XML. And basically, you have to do something with it. It's called XPath. XPath is XML's answer to, I don't have SQL. Okay. It'll look something like this. We'll start with the root. Select nodes. Select nodes takes an XPath string. Again, you can go out to XPath and read up all about it. It's fun. It's good stuff. You scratch your head for days trying to get something to work until you finally understand it. I believe this gives me a node list. We'll call this XML patients. So what that did is it's going to parse through the entire document and return back every instance of patient, of the patient element, in all of its child nodes. We then do a for each. Across XML patients. And then we can say p.firstname equals xpatient dot, doesn't know what it is, object. Then we can say select single node, first name dot value, or enter text. Before I get into that. Alright, so what's this doing?
Root element, plist, list of our patients when we're done. XML patients is a node list. Root.select nodes. Backslash or // patient says anywhere in the document you see patients, go find them, seek them out, and collect all of those nodes. Get references to each node. Put it in a list. This becomes a list of just the patient nodes. Just the patient elements, nothing more. So now we have an isolated group of patients only. We don't have to worry about conditionalizing it, doing if statements. Is this a patient? Is it not a patient? We now can assume they're all patients. Loop through the patients. For every patient we loop through, create a new patient object that we're going to transfer that data from the XML into the patient object. We then say P, the new patient first name, equals patient.select single node. There are still nodes inside of patient.
The XML patient.
First name, last name, email, phone, street address. Those are nodes inside of patient. So we're then using XPath again.
And instead of doing the double slashes, we're being explicit, we're being context specific. We're saying, go find the first name node inside of this patient.
So select that node, capture it, and then take the inner text from there and put it in the first name. Yeah.
How would you get the patient ID out of it?
I would probably actually do it in 3 steps. I create a patient ID string because it's going to come as a string. You still do select single node. You do it like that, and then you would grab value.
So the @ sign designates it as being a attribute, not an element, because it is an attribute. And that's why I said you want to have consistency, because if you create one patient object as an attribute and you create the other one as an element, you have to deal with this, which one is it?
So then we have it as a string, and then we would do p.patientID equals int dot, let's assume that it'll work, parse str patient ID. You'd probably end up doing int PID, and then you do a try parse out PID if p.patientID equals PID. It's not try parse parse, try parse. So go get the string and then attempt to parse that string into an integer
PID. If it parses successfully, if this returns true, take PID and push it in patient ID.
I'm pretty sure I have all of my XPath correct, but I may not. Did blow up, so that's a good sign. plist has 2 items. There's the first one, and there's the second one.
Woohoo, I did it work. Half the time I do this, and I always mess it up for whatever reason. I always mess up my XPath stuff. I'm proud of myself. Huh? So that's XML parsing. So the goal here is to make it more readable, to make it easier to read, easier to understand than doing all these for each loops, looping through everything, trying to figure it out, hoping for the best, blah, blah, blah. You can at least see the flow. Go get the patients. Loop through the patients. This should hopefully look very similar to what we did for the database. Then, for every patient, create a patient object and transfer that data over. The goal here is to end up with a list of patients that you then can pass on to your application so that it can do work.
I know in ASP.NET the grids are pretty smart. No, that's not what I wanted. Oh, come on. Open XML, open, patients. Oh, I did do it.
It looks the same. What's different? I took a list of patient objects and I bound those to the grid. The grid is smart enough to say it's a collection, treat every patient like a row, looks at the properties, and it deduces that those properties should become fields. We basically took an object and kind of indirectly made it back into a database table. You can see parallels. They are in a database table. They're just being presented that way because that's what the grid does. But that's kind of the end goal, the balance, checks and balances. Now, obviously, you can do much more with a collection of patient objects than just simply bind them to a grid. But this at least shows you that we were able to parse the XML document, pull that data into an object, take that object then and push it out to the user interface and present it in at least somewhat of a usable way. So this idea of pushing and pulling data is the most simplistic concept, in my opinion, when you're building any sort of business level application. Is the basic fundamental thing that you need to have an understanding of. If you're working in any type of business, profit, nonprofit, education, medical, whatever, and you're working in the IT field, unless you're building and writing software to run mechanical systems, you're probably going to be dealing with data. Even if you're coding video games, you're going to end up dealing with data, but you're dealing with a different type of data. You're dealing with input from the user. And how does that input respond on the object models that you're using in your video game? So your game takes these objects and it renders them out on the screen. The user playing the game pushes an input from the controller. You then have to take that input, serialize it, process it, and then have your object, your character, respond. Same mechanics. So understanding these mechanics, regardless of where the data is coming from and what the data is doing, is going to be the fundamental piece to being successful with writing any sort of application. whether your data is coming from a controller, a database, an XML document, a web service, a flat file, somebody tapping on a button somewhere, or audio streams, you're going to be dealing with data coming into your system. And then how do you handle it? What's the easiest way to handle it? Store it in an object. You then have full control over what that data can do. Okay? All right. Any questions? Clear as mud, clear as a dirty windshield. I figured dirty windshield you can kind of see through it, so I was trying to one level above mud.